And welcome back. And it's the 3rd of Feb today, and it's the Corbett 5 a day. Let's go with the first 5 questions. Right, first question. Make R the subject of the formula. This is what's often called the difficult questions because there's 2 R's, but the process is always the same. I need to move all the R's to one side and everything's not an R to the other side. So let's start by expanding my equation. So that's going to be 8R plus 1 is equal to 15RV plus 15V. And that's how I'm going to move everything with an R to the left and everything without an R to the right. So that's going to give me 8R minus 15RV is equal to 15V minus 1. And then I'm going to factorize out the R, which is going to give me R 8 minus 15V is equal to 15V minus 1. And then divide by the left-hand bracket, and that's going to give me R is equal to 15V minus 1 divided by 8 minus 15V. Which, of course, you could write the other way around, so 1 minus 15V over 15V minus 8. Also fine. First question done. Next question. What do we have? Shown below is a triangle ABC. Give me some coordinates. Q is a point on AC such that, it's a ratio question. So in other words, that's 2 parts. I'm going to do that different colour because it's clearer. So this is 2 parts and that's 1 part. And then it says work out the length of BQ. So it wants this length down here. Okay, so the way I'm going to do this is basically just find out what the coordinates of Q is. Now you've seen me do this sort of thing before. If I know, there's a couple of ways of doing this, but I'm going to do it vector method because I always think getting used to vectors is a good idea. So A to C is from 2 to 14, which is across 12, and from minus 4 to 5, which is up 9. Now A to Q is 2/3 of that. So A to Q is 2/3 of 12, which is going to be 8, and 2/3 of 9, which is going to be 6, which means the point Q is going to be, well, I'm going to start from the A value, so it's going to be the 2 here plus 8, which is 10, and it's going to be the minus 4 here plus 6, which is going to give me 2. So in other words, I know the point Q is 10, 2. And then it's just a case of working out the length of B to Q. So this is just Pythagoras, isn't it? So B to Q, well, B, so using my B value here, so from 5 to 10 is across 5, so 5 squared. 10 to 2 is down 8, but I don't really care about the negative, so 8 squared. Get my calculator out, and that's going to give me 25 plus 64, which is the square root of 89. It doesn't give me any sort of reference in terms of significant figures, so I'm going to leave my answer like that. Question done. Next and final question today. Line L is a tangent to the curve, and it gives me an equation. At the point 310, work out the equation of L. Okay, so this is just a find a gradient and work out the line tangent question, isn't it? This is basically ensuring you understand that the tangent has the same gradient as the point on the curve at that point, if you see what I mean. In other words, I'm going to differentiate. So if I differentiate this, that's going to give me 4x minus 3. Then at the point x equals 3, my gradient, so my dy dx, is equal to 4 times 3, which is 12, minus 3, which is 9. So my gradient is 9. I want tangent, so it's the same gradient. So I'm going to use y equals mx plus c this time, just to be different. So y equals 9x plus c. Use the point 310. So 10 is equal to 9 times 3, which is 27, plus c. In other words, c is going to be 10 minus 27, which is minus 17, minus 17. Put all that together, clear answer, 9x minus 17. And that's today done. Good mix of questions again today. I hope it all went well for you. As ever, do like and subscribe, and I'll see you for the next set of questions. Thanks all.